Ow. Oink. Hi again, guys. Who's ready for some more math? I know I'm ready for math. Come on, let's go.
Ducky! Meh?
Oh, we almost forgot about you, Chicky.
Ducky! Woo! Ow!
Oh.
Sorry. Ducky.
That's very polite of you, Chicky, moving out of the way so that Byron can have space to breathe.
Phew. Hi, I'm Sibby.
S-I-B-B-Y.
Sibby, the talking baby hippo. And I am one of Byron's friends.
Yes. Yes, I am. Today we are learning about probability and likelihood. Those are two other very special things that we're going to talk about in our math data lessons. Remember last time when we went over sample space? We figured out the sizes of sample space and we knew how to represent them with drawings, tables, and tree diagrams. And we knew that the beginning letter of each word is the first letter of each word. Violet starts with V, so we draw V. Well, this time, it's a completely different lesson, but it's going to be super fun. It's called Probability and Likelihood.
Oh, hi guys. Ooh, a vocabulary box. Romeo, come over here.
Yes, Juliet? That's a vocabulary box. And you know what that means?
Yes, I know what that means. It's vocabulary time.
That's right, Juliet. When we see a vocabulary box, it's vocabulary time. It's time to know our math words. Aw, yeah. Cuckoo! I think Cuckoo the Cuckoo Bird is excited to learn about our math vocabulary words, are you?
Cuckoo! 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 Cuckoo is very excited. Oh, and by the way, I'm Squeak.
Yeah, we know. We met you before.
Oh, right. Sorry, forgot. There are Mango, Fudgy, Ellie, and Wally. Those are our names. Right.
So, anyways, what's the first word in that vocabulary box, Cuckoo?
Cuckoo.
That's right. The first word is sorry, I'm very terrible at reading. Hold on. It's probability, Byron. Oh.
Here are
Sure. Well, sometimes I can be good at reading because I've got a reading tutor, but I can struggle with reading still. So I'm good, but at the same time not good. A probability is a number from 0 to 1 inclusive that describes how likely it is for an event to occur. Oh, so probabilities are number scaling? That's right. When it's for probability, the numbers are to scale. So from 0 to 1, that's the entire probability set. The entire set of what could be considered likely or unlikely. This number line shows how a probability describes the likelihood of an event. The likelihood of something is how probable or likely an event is to happen. That's why it's called likelihood, because it has likely in it. Although L-I-K-E-L-I is the wrong spelling for likely. It's actually L-I-K-E-L-Y. But the likely part in the likelihood is the correct spelling in likelihood, so don't worry. It's not the wrong spelling. Alright, this is the probability scale. As you can see on this 0 to 1 number line, we can include all of these from 0 to 1 in the number line because it's a line. Lines go on forever. And so do numbers. So we include all the numbers from 0 to 1. All the decimals and fractions, that is. So, when an event has 0 probability, it means it's impossible to happen. When something is impossible to happen, it means it could never happen. Yes, one notable example that I think you should all know is that pigs do not fly. Yes, so the event pigs can fly would be impossible, because pigs cannot fly. Pigs evolutionarily cannot fly. They have lost the ability to fly. Anyway, so that is an impossible event, because pigs mostly walk. They don't really fly. So, an unlikely event is a probability that is greater than 0, but less than 1/2. For example, 1/3 or 1/4. That would be in the unlikely scenario. Unlikely means that it will probably not happen, but there is still a small chance of it happening. So it's not impossible, it's not 0, but it's a very small chance of it happening. So, and 1/2 is equally likely or unlikely to happen. So there's a 50-50% chance of it happening in this 1/2. So equally likely, equally likely, or unlikely. You could call it any of those. Gradually, when we go up from the unlikely scale, we use equally unlikely. When we go down from the likely scale, we use equally likely. So that makes sense. And the probability that is greater than 1/2, but less than 1, is called likely. Likely means that it will probably happen, but there's a small chance of it not happening. So, and then the likelihood of 1 means certain, meaning that it's 100% going to happen. So, these are all of the likelihood scales. Impossible means that it cannot happen at all. Unlikely means it will probably not happen, but there is a possibility. Equally likely or unlikely means a 50-50% chance of it happening or not happening. Likely means it will probably happen, but there's a small chance of it not happening. And certain means it is 100% going to happen. So, those are all the likelihood and probability scales, from 0 to 1. Impossible means there's a 0% chance of it happening, like at all, like the pigs flying scenario. For each event in the table, use the words on the number line to describe the likelihood. Ooh, this should be fun. Sibby, can you read this event, please?
Sure. A rolled 1 to 6 number cube lands with 8 up. Wait a second. It's a 1 to 6 number cube. The smallest number in that cube is 1, because it does not go from 0 to 6. It goes from 1 to 6, and plus, the highest number is 6, not 8 on the cube. So, wouldn't it be impossible to roll an 8?
That's right. It's impossible to land with an 8 up, because, like you said, Sibby, it's a 1 to 6 number cube, meaning that the highest number on that cube is 6, and no higher. 8 is higher, so it breaks that rule. So, remember the sheep scenario? Like, if you only have 6 sheep, you can't have 8, because 6 is not equal to 8. 6 is less than 8. So, and remember that Touch and Teach turtle toy I showed you guys? Well, the Touch and Teach turtle also has number keys, which is going to be very helpful here. Let me just bring it out. Yes. Oh, nostalgia's kicking in. Alrighty now. These are the number keys. As you can see here, this is a 1 to 6 number cube. So if it's 1 to 6, then we can easily see that it only goes up to 6 and goes down to 1. Just like the number cube, this Touch and Teach turtle toy has a minimum number of 1 and not 0, but it has a maximum number of 8. So 1, 2, 3, 4, 5, 6 is all the numbers on the 1 to 6 number cube, but 7 and 8 are not included because they are both greater than 6. So that's why it's impossible to roll an 8 on a 1 to 6 number cube if it's labeled for 1 to 6. Huh? unless it's labeled with an 8, it would be pretty much so impossible to roll an 8. Because, like we just said over and over again, it's a 1 to 6 number cube. The highest it could go is 6, not 8. So it's impossible to roll an 8. This means that there is a 0% chance of rolling an 8. That's it. That's all you have to do. That's a 0% chance of rolling an 8 because it only goes up to 6, not to 8. Look how further apart 6 is from 8. That's how you can know that 6 is less than 8, because it is further away from 8. 7 is further away from 8, but only 1 further away. 7 is still less than 8, but only 1 less than 8. 6 is less than 8, but is 2 less than 8. 5 is 3 less than 8. 4 is 4 less than 8, and so on. So, you see, this Touch and Teach Turtle number toe pattern can help us with the numbers. Let's do another one. A rolled 1 to 6 number cube lands with 3 up. Let's see if 3 is in the sequence. 1, 2, 3, 4, 5, 6. Yes, 3 is in that sequence. The number 3 key, it shows a cute little monkey, is included in the 1 to 6 key range, which means that the number 3 on the cube must be included on the 1 to 6 number cube range. So, it is possible to roll a 3. But how possible?
Wait a second. 3 is only one of those 6 numbers, right?
Yeah.
Cuckoo.
That's a very great question, Cuckoo. Cuckoo asked me, how do you tabulate that?
Oh, good question, Cuckoo.
To tabulate that, we first need to look at the amount of numbers. Well, as Juliet said, 3 is only one of the 6 numbers. So that would be 1 divided by 6. 1 divided by 6 is way less than 1/2. Let's check to see what 1 divided by 6 is. We can easily figure this out. 1 divided by 6. I know this answer, but I just want to double check to see, because it's never wrong to double check. So, 1 divided by 6 is 0.1666666, with the 6's repeating. 0.166666666, that's a lot of 6's, has only 1/10, but 1/2 has 5/10. 1/10 is less than 5/10. So, it is less than 1/2, but it's greater than 0. This means that it's unlikely, but possible. Remember that. It's not impossible to roll a 3, because 3 is in that range. It is just unlikely, because it's only one of the 6 numbers. And that is 1/6, which is less than 1/2, but greater than 0, which fits in the unlikely column. However, it is still possible, because as we said before, unlikely means it will probably not happen. However, it will have a small chance of it happening. So, it's not impossible. That's why it has a small chance of it happening, because it's not nothing, so it's not 0. It's not impossible. It's just not going to happen unless a very slim chance occurs. Unlikely, but possible. Remember, it is possible to roll a 3. Just very unlikely on occasions. Anyway, a tossed coin lands heads up. How many surfaces are on a coin?
2?
The front and the back? That's right. A coin has 2 surfaces, a front and a back. Usually the heads is the front and the tails is the back. So there are 2 of those surfaces, meaning that there are 2 numbers. If a tossed coin lands heads up only, then what do you think the likelihood for that event to happen is?
Ducky.
Good idea, Chicky. Try to answer this question.
Ducky.
Yes, the front is one of the two surfaces.
Oh, Ducky!
What's Chicky doing?
You'll see, Romeo, you'll see. Ducky! Yeah!
Oh, that's very smart, Chicky. Chicky is dividing 1 by 2, and he got 0.5. Wait a second. Heads is one of the two surfaces of a coin, which means one of those two is half of 2, because half of 2 is 1. That's 0.5, which is equal to 1/2. So, if we look at 1/2 here, it says equally likely or unlikely. So, you're right, Chicky. Wow, you're blasting off today. The likelihood for this event is equally likely because 1 is half of 2. So there's a 50-50% chance of it happening or not happening. Equally likely or unlikely to land heads up. So that means 50% of the time it will land on heads. But the other 50% of the time it will land on tails. That makes sense because 100 divided by 2 is 50. So, and 10 divided by 2 is 5, just for a scale. And 1 divided by 2 is 0.5. You notice all those 5s there? It's just 10 times less. So, yes, 1 divided by 2 is 50. 10 divided by 2 is 5. 5 is 10 times less than 50. 5 is 10 times less than 50. Sorry. And, yeah, 10 times less. So, that's just a repeating pattern. That's equally likely to happen. Equally likely or equally unlikely to land heads up. Because it's one of the two surfaces, heads or tails. So, now, a rolled 1 to 6 number cube lands with 3, 4, 5, or 6 up.
That's a tricky one. Oh,
Maybe we can answer.
and me too!
Great idea. Bring out as many people.
Cuckoo! Yay! Let's see about this one. Cuckoo? Dun, 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 dun. Cuckoo!
That's right, Cuckoo. Those are 4 numbers. 4 numbers. Oh, wait a second, Cuckoo. You may have cracked something. Not a bad thing, but a good thing. You're cracking the case. Look, 3, 4, 5, and 6 are 4 of those 6 numbers. 4 divided by 6. Chicky, do the calculations.
Ducky!
4 divided by 6 is 0.6 repeating. But 1/2 has 5/10, while 0.6 repeating has 6/10. You notice tenths? It's not tens, it's tenths, with T-E-N-T-H-S, tenths. 6/10 is what 0.6 repeating has. But 1/2 only has 5/10. So 5 is less than 6. So 6/10 is greater than 5/10. So it's greater than 1/2, but less than 1. That puts it in the likely scenario, which means that it's likely to roll a 3, 4, 5, or 6. But it is also unlikely with a very small chance of it not happening. So you see, it is also likely only for a small percent to land on a 1 or 2. So you see, it is most certainly likely to roll with a 3, 4, 5, or 6, but every likely event, not certain, has a small percent of chance of it not happening. So for every likely it is to roll a 3, 4, 5, or 6 up, it is also likely, but a very small chance of it being likely, to roll a 1 or a 2 as well. Because those are the other 2 numbers. Yes. So, yeah. Likely scenario. That is likely. And a tossed coin lands heads or tails up.
Wait a second. Is that already both of the surfaces?
Oh yeah, I didn't even notice that. Come on, let's bring out a different group. Great idea, Byron. Bring out a different study group each time. Don't worry if you want to work with the same people. It's fine. Heads and tails? Wait a minute. 1, 2. Those are 2 of the 2 surfaces. 2 divided by 2? I think we know what the likelihood is. 2 divided by 2 is 1. Where's 1? Oh, it's there. 1 is in the certain category. So, the likelihood of landing heads or tails up is certain, because a coin only has heads or tails. So the chance of rolling heads or tails is certain. It's 100% going to happen, heads or tails, because those are the only 2 surfaces of a coin, the front and back, the heads and tails. So it's certain that either one of those surfaces will be flipped over. So it's certain, 100% going to happen. For all outcomes of an experiment to be equally likely, each outcome must have the same chance of occurring. Like this one, a tossed coin lands heads up, or a tossed coin lands tails up. These are both equally likely events, because heads is only 1 and tails is only 1 of the surfaces. So,
Yeah, that makes sense.
because we're Romeo and Juliet, right? No matter what person we are always only one person. Yeah, I'm Romeo, but I'm still one person.
And I'm Juliet, but I'm still one person.
Yes, it's the same thing for coins. A coin can have a front, but that's still a surface, and a back, which is also still a surface. So, yeah, that makes 2. 1 plus 1. When you roll a 1 to 6 number cube, each number from 1 through 6 has the same chance of being rolled, so the outcomes of 1, 2, 3, 4, 5, 6 are equally likely. This is a scenario where rolling these 1 to 6 number cubes do not have a likely or unlikely chance. It's equal. When you roll a number cube with 2 2s, 2 4s, and 2 6s, each number from 1 through 6 does not have the same chance of being rolled, and the outcomes 1, 2, 3, 4, 5, 6 are not equally likely.
What?
But it's 2 2s, 2 4s, and 2 6s. Those are the same. Yes, Byron. But 2 4s are more than 2 2s. And so is 2 6s. And, plus, the results are very uneven when we summarize this up. Oh, yeah! I forgot about that. Write equally likely or not equally likely to describe the outcomes of spinning each spinner. Ooh!
I like that spinner. It's divided in half.
That's right, Juliet. This spinner is divided into 2 equal pieces. Those are 2 halves. 1, 2.
Oh, and the pieces are equal. They are 2 equal semicircles.
That's right. Half of a circle is a semicircle. And those semicircles are both almost the exact same shape. So will it be equally likely? Yes, it will be equally likely, because both of the pieces are equal. So it's equally likely to spin a 1 or a 2, because 2 is divisible by 2. That's 1. It is certain to spin a 1 or a 2, but it is only likely to spin a 1 only, or spin a 2 only, because that is only one number. So look, 1 is a number, but it is still one number, and 2 is a number, but it's still one number, because that's only the 1, 2 there. So, yes, 2 can be cut in half. That's what makes it equally likely. Look out for numbers that are not divisible by 2. That tells you it's not equally likely. Let's look at this one. Ooh, this spinner's also divided in halves, kind of. But what do you notice about this one? The key? Ding! Chicky is right. He's getting a little suspicious. There's a 3rd piece on the spinner, but no 4th piece. 3 is not divisible by 2, though. because that would be 1.5. And that's not a whole number. It's not even. So it's not equally likely. So it may be unlikely or likely. Yeah, it may have a higher or lower chance of it happening. Predicting the higher and lower chances of these ones happening can be very simple. If the size of the pieces are big or small. Like, for example, 1 is a very huge piece. It is probably very likely that it will land on 1. But 2 and 3 are very small pieces, so it may be unlikely to land on 2 or 3 only, unless it goes to the other half. So, although 1/2 plus 1/4 plus 1/4 equals 1 whole circle, those are only 3 parts, not an even number of parts. It should be 2 parts of a circle or 4 parts of a circle. That's 3 parts of a circle, which is not divisible by 2, so it's not equally likely. Remember, for an event to be equally likely or unlikely, it has to be exactly 1/2. But 3 cannot be divided equally in half without leaving some 0.5s behind. Like 1.5 times 2 is 3, but that doesn't count because 1.5 is a decimal, not really a whole number. So it's not equally likely. Look out for these. Okay, let's look at this one. Ooh, 1, 2, 3, 4.
Hey, wait a second. That circle is divided into 4 equal pieces. Oh, yeah. And each piece appears to be the same size and shape. So, is it equally likely?
That's right. For this spinner, it is equally likely. Because look at all the pieces. They're the same size and the same shape. So it would be equally likely to roll either one of those. Either 2. So, the possibility of spinning a 1 or a 2 or a 4 or a 3 are both equally likely because those are 2 of the 4 numbers. 4 is divisible by 2 as well, so it can split in half. Remember, half is equally likely or unlikely. That's why this one for 1, 2, 3 is not equally likely because 3 cannot split perfectly in half without leaving 1 left over. But 4 could. 2 2s. 4 divided by 2 is 2. So in other words, half of 4 is 2. So that's a half. And a half is equally likely or unlikely. We need to do half of the total number of parts of the spinner in order to determine if it's 1/2 or not. If it's not 1/2, it's not equal. If it is 1/2, it is equal. And in this case, it is equal. Equally, because 4 can be divided in half. Let's look at this one. 1, 2, 3, 4. 4 parts. Well, there are 4 parts. Wait a second. Something feels a little odd about this spinner. Can you come over here, Juliet?
Yeah.
What's up, Romeo?
Oh, that spinner looks pretty cuckoo. Yeah, it looks pretty cuckoo. Well done, cuckoo. Oh, this one looks pretty cuckoo.
I don't think all of these pieces are the same exact size. I think 2 are larger and 2 are smaller.
That's not right. All the pieces should be the same size. Cuckoo! Cuckoo?
That's right, Cuckoo. For this one, it is not equally likely. Remember, the amount and the size matters. You see? Look. 4 and 2 are very large, but 1 and 3 are only very small pieces. That's not equal, because in order to be split in half perfectly, all the pieces need to be an equal size. Like this, 4 quarters, 4 shaded quarters of a circle are 4 equal shapes. But for this one, it has 2 very large parts and 2 very small parts. Those are not the same size, so that's not equally likely, although it has a 4 in there. Remember, it's not only about the number, but also the size. 4 divided by 2 is 2. You also have to check on the size and see if they are equal to each other. But these are not the right sizes, so this is not equally likely. It may be likely or unlikely, but it's not equally likely or unlikely, because it cannot be split perfectly in half. Although we could theoretically split it in half if we split it down the middle, which reflects it, that only reflects it. And, plus, that doesn't really count, because in order to split it down the middle further, we need to make it completely equal. This is not completely equal, so it's not equally likely. Well done, guys. Looks like you're telling the difference between equal and unequal likelihoods. I'm sorry, this Touch and Teach turtle is really in the way. We'll save that for later. Alright, get off the book. This is the next page. Now we are going to learn how to calculate probability.
Ducky? Yes, Tricky, you can calculate probability. I just don't know how. Cuckoo! Oh! Let's read. When all outcomes of a probability experiment are equally likely, the probability of an event is the ratio of the size of the event to the size of the sample space.
Oh yeah, Baby Hippo may be right. So, when all of them are equal, then we need to divide the size of the event by the size of the sample space.
I was right after all.
So, everybody, the formula you need to know is, when all outcomes of a probability experiment are equally likely, the probability of an event is the ratio of the size of the event to the size of the sample space, which is equal to size of event divided by size of sample space. That equals the probability of the event. So that's how you calculate probability. Very simple. Lucy rolls a 1 to 6 number cube. She wonders what the probability of rolling an odd number is. That is a very, very good observation. Find the sample space in the event and their sizes. So first, she writes the sample space. The whole entire sample space is 1, 2, 3, 4, 5, 6, because it's a 1 to 6 number cube. It goes up to 6 and down all the way to 1. The size of the sample space is 6, obviously, because 1, 2, 3, 4, 5, and 6 are 6 different numbers. And if we want to roll an odd number, then the event is 1, 3, 5, because 1, 3, and 5 are all odd numbers, and they're not divisible by 2. Notice the brackets and parentheses, guys. The event should be in parentheses, but the sample space should be in brackets. You should really notice that. Look at the difference between the brackets and the parentheses. The event is 1, 3, 5, because again, like I just said, 1, 3, and 5 are all odd numbers. So what is the size of this event? 3? That's right, Romeo. The size of this event is 3, because 1, 3, and 5 are 3 different numbers at once. 1, 2, 3 numbers in the parentheses. So the size of the event is 3. Use this information to calculate the probability. Okay, so the size of the event is 3. The size of the sample space is 6. The formula is size of event divided by size of sample space. What's the size of the event? 3. And what's the size of the sample space? 6, of course. So 3 divided by 6 is 1/2. The probability that Lucy rolls an odd number is 3/6 or 1/2. This means that there are 3 chances out of 6 that Lucy will roll a 1, 3, or 5. Because 1, 3, and 5 are 3 of those 6 numbers. And 3 is half of 6. So it's equally likely or unlikely to happen. See, this is the event that goes after the P. And then event divided by sample space, those are the sizes divided by 3/6, which is also 1/2. We can double check to see in our handy dandy cash register calculator. 3 divided by 6, that's also 0.5. and 0.5 is equal to 1/2. So that's conclusive proof of how we know that the likelihood of this event is 1/2, or equally likely or unlikely to roll a 1, 3, or 5. Sam reaches into a bag containing 12 number tiles with the numbers 1 through 12. He removes one tile without looking. What is the probability of him taking out, let's say 7, taking out a 7? Look at it this way. Are there 6 of the 12 numbers? No, 7 is only one number, so we know it's not equally likely. If it's not equally likely, we do not use this formula. Remember, that's only for equally likely or unlikely scenarios. So, it says when all outcomes are equally likely, the probability of an event is the ratio. But when it's not the ratio. So we don't have a ratio already, because 7 is only one of the 12 numbers instead of 6 of the 12 numbers. That makes sense, because 6 is half of 12, and there are no 6 numbers. He says he only peeks one tile. Removes one tile without looking. So that's one of the 12 tiles. 1 divided by 12. Let's see what that is. That's an extremely small answer. 0.083333. That's definitely way less than 0.5. So, it is unlikely that he will remove a 7, but it is still possible. Remember, it's not impossible, because 7 is only one number, not 0 numbers. Be careful. 7 is only one of the numbers. And although it's unlikely to get a 7 on the first try, he may get it on the second, or more accurately, 4th try, if he does it again and again and again, and expecting different numbers until the number he peeks out is 7. So it's unlikely to pick out a 7, but it is still possible, because it's not impossible. It's not a 0% chance. It's just a 0.083333% chance, which is slightly more than 0. That's barely anything. But there's an extremely small chance of it happening. Remember that. Remember that. So now, we are going to check out this spinner. We are going to do very simple concepts with it. How many parts does the spinner have? Goo, 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 goo. That's right, Cuckoo. The spinner has 8 parts. Well done. So, how likely would it be to spin a 10? A 10? I don't see a 10. That means it's impossible, right? That's right, Romeo. It only goes up to 8, not to 10. Let's bring out the Touch and Teach Turtle toy again. The Touch and Teach Turtle toy only goes up to 8. It does not go up to 9 or 10. It doesn't go up to 10. It only goes up to 8. Same thing with this spinner. It only goes up to 8. So it would be impossible to land on a 10 because it only goes up to 8, not 10. So the maximum number on this spinner is 8, not 10. So that's why it's impossible to land on a 10. Alright, let's do one last one. How likely is it to land on a 2, 3, 4, 5, or 6? That's a tricky one. Let's count all the numbers. 1, 2, 3, 4, 5. That's 5. 1, 2, 3 left over.
Wait a second.
5 plus 3 is 8. And those are only 5 of the 8 parts. Divide 5 by 8. And that's equal to 0.625. That's greater than 1/2, but less than 1. Which means that it's likely to land on a 2, 3, 4, 5, or 6. But there's a small chance of it not happening because you can also land on a 1, 8, or 7, which is the other 3 parts. So it's likely, but not 100% going to happen. It's not certain, not 1, it's just very close to 1. Yes, it's like 0.6 is not exactly 1, but it just rounds up to 1, because 0.6 is pretty much closer to 1 than to 0. So, it rounds up to 1, but it's not 1 exactly. So, yeah, it's only likely there. Well done, all of you. Looks like all of you are becoming masters of this already. Alright, time for a table!
Wow, that's lucky.
Yes, that was lucky. A table is a much simpler way to represent probability and likelihood. The probability is the number. The likelihood is the chance of it happening. So, if the probability is 0, the likelihood is impossible. It's 0% going to happen if it's impossible. If it's unlikely to happen, it will probably not happen, but will have a small chance of it happening. Greater than 0, but less than 1/2. See those comparison symbols! If it's equally likely or unlikely, there's a 50% chance of it happening and a 50% chance of it not happening, which is exactly 1/2. Equal. If the event is likely, it is greater than 1/2, but less than 1, meaning that it will probably happen, but there's a small chance of it not happening. And, finally, if the likelihood is certain, this means that the probability is 1, and that it's 100% going to happen. An event is 100% going to happen only if it is certain to happen, because certain means 100% going to happen. That's why people say certainty, or certain, to approximate 100%, or guarantees. Guarantee is another word for saying 100% going to happen. Like you guarantee it's going to happen. If you guarantee that something is going to happen, you are not saying it has a 70% chance of it happening or 25%. No. When you guarantee something, you're saying it's 100% going to happen. No matter what day it is, regardless of the time, you guarantee something, it's 100% going to happen. It's a certain event in the real world. So that's an example of events from the real world. Certain is 100% going to happen. Impossible is the complete opposite. 0% going to happen. Let's look at this text. The probability of an event tells the likelihood of the event happening. A probability does not tell what the next event will be, just how likely it is that the event will happen. So, it does not tell us the events, but it does tell us how likely or unlikely the next event will probably happen. So, these are the numbers. Harold tosses a coin 4 times. It lands heads up all 4 times. To describe the likelihood of this event, find the probability that the coin lands heads up when he tosses the coin again. Well, this may be very hard to estimate because we can't exactly predict what will happen when he flips the coin again, because it doesn't tell us. But we can predict. Remember, there's no right or wrong answers here. It's only a prediction at this point. What is the event for this coin toss? Alright. Since Harold tosses a coin 4 times, the event is rolling 4 heads. So the sample space for this coin toss is H, 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 or 4H, all 4 of those H's. Find the probability for this event. Alright, if it lands on heads up all 4 times, we can do this in 2 completely different ways. There's no wrong answer because we can tabulate it somehow with a simple explanation. 1, we could either do equally likely or unlikely if we are talking about heads and tails. If we land 4 heads but no 4 tails, 4 plus 4 is 8. 8 divided by 4 is 2, which is half. 4 is half of 8. So, if we are rolling 4 heads in a row, but left 4 tails to not equal 8, then it will be equally likely, because half of 8 is 4. So we could do this one way. One, we could say equally likely if we are including heads and tails 4 times, because if we roll heads or tails 4 times, that would be 8 out of 8, which is certain or 100% going to happen. However, 4 heads is only half, which is 1/2, which is equally likely or unlikely. Or we could do another one, number 2. We can do number 2, likely or certain going to happen. We could do the opposite. Number 2 can be the opposite. Remember, there's no right or wrong answers because we're just predicting. If we are only talking about heads and we're not talking about tails, then the event would almost be certain, because 4 out of 4 is 1, which is certain. However, there is a small chance of it landing a tails on the next go. So that's why it would be 3/4 or 4/4, which is 1 or 0.75. Which, again, those are some great estimates. But again, no right or wrong answers. Just predicting right now. There may be a right or wrong answer later on when you are actually provided with this question 24. But for right now, there's no right or wrong answer. Out of the 2, you can pick. If we are talking about 4 heads and 4 tails, he only rolled 4 heads. So that's equally likely because 4 plus 4 is 8. 4 heads and 4 tails equals 8 heads and tails. And 8 divided by 4 is 2, which is half, equally likely. Or, if we're only talking about heads and not tails, then it is certain that he will roll 4 out of 4 of those heads. Because 4 divided by 4 is 1, which is certain. The probability for the next event is probably going to be either 3/4 or 2/4 or 1/4. It may even be 0. But, I think 3/4 is a good stopping point. Describe the likelihood that coin lands heads up if he tosses the coin again. Likely or certain? Now, there's another way we can do this. Number 1, you can say it's unlikely, that is, it can roll something else more, or we can say it's equally likely or unlikely, if both of them are equal again. Sarah tosses a 1 to 6 number cube. How likely is it that she tosses a 3? Let's count the numbers. 1. 3 is one number, one of the 6 numbers. And as we did before, Chicky, do that again. 1 divided by 6 is a lot less than 1/2, but greater than 0. So it's unlikely, but possible. Remember, unlikely is not impossible. Because look, although it is less than 1/2, it's greater than 0. So that means it's greater than impossible, which is not impossible. That's unlikely, not impossible, just unlikely. It has a very small chance of it happening because an unlikely event has a probability of between 0 and 1/2. It's not really completely 0. It's just a very small portion. So it's not 0. 0 would be impossible. Unlikely does not have a 0. Remember that. Unlikely means probably will not, but has a very small chance of it happening. So remember that. Not impossible, just very unlikely. Sorry, stuttering today. How likely is it that she tosses a 1, 2, 3, or 4? Alright, let's practice this.
1, 2, 3, 4.
Those are 4 of the 6 numbers. And 4 divided by 6 is 0.6 repeating. That's greater than 1/2, but less than 1, which means that it's likely. So, the likelihood of her tossing a 1, 2, 3, or 4 from a 1 to 6 number cube is likely. But it can be unlikely in a very small percent of the experiment. Because remember, likely is not completely 1 because it is less than 1, but greater than 1/2. So likely. It's not certain, but likely. Likely. It probably will, but we don't know if it's 100% going to happen. Probably not. So, yeah. Likely, but not 100% going to happen. It will probably happen, but it's not 100% going to happen. Like, the vast majority, like, 75% of the time it's going to happen, 25% of the time it won't happen. See, that's likely. That's likely. That's 3/4. Because 3/4, which is 75%, is greater than 1/2, but less than 1. That's likely. And how likely is it that she tosses an 8? Alright, we already went over this before. Let's recap. Let's look at the Touch and Teach Turtle toy. Remember, this is a 1 to 6 number cube. On such a cube, the numbers only go up to 6. 1, 2, 3, 4, 5, 6. And where's 8? Over here. It's much farther away from 6, so it's greater than 6. That's the problem. The cube only goes up to 6, not to 8. So it's impossible to land on an 8. So the likelihood of this is 0. Because it can only go up to 6, not to 8. So again, 6 sheep are not 8 sheep. That breaks the rule. So it's a mathematical error. That would be impossible because the 1 to 6 number cube only goes up to 6, not to 8. So that's why it's impossible to land on an 8. Alright, I'll do these last 3 to show you. I think I may have done a little error here. I was too busy messing around. Circle the likelihood of each event. There are 8 parts of this spinner, just like the other spinner we looked at. Spinning a 2 or 3 will be unlikely. You want to know why? Not impossible, but unlikely. You want to know why? That's because 2 and 3 are only 2 of the 8 numbers. And 2 divided by 8 is the same thing as 1 divided by 4. Which is 0.25. That's less than 1/2, but greater than 0. So that's unlikely. See? Unlikely. But not impossible. Because 2 and 3 are the numbers. And if they exist, then a small part of it happening will exist. Unlikely is the likelihood for this one, spinning 2 or 3. Spinning a number that is not 2 or 3 will be likely, but not certain. Because if we remove 2 and 3, if we remove 2 numbers from 8, that'll be 6. 1, 2, 3, 4, 5, 6. 6 out of 8. And 6 out of 8 is 0.75, which is, again, greater than 1/2, but less than 1, which is likely. This is likely, because 6 is greater than half of 8, and half of 8 is 4. So 6 is greater than 4. Again, let's reference. 6 is further away from 4. So 6 is much larger than 4. Although it is really only two times larger. I mean, 2 larger. So 5, 6, see? So it's likely that we are going to spin a number that is not 2 or 3. But it is also likely in a very small chance that we can spin 2 or 3, because 2 or 3 still exists. And if that exists, then spinning a 2 or 3 will exist, but in a very small percent of chance. Because spinning a number that is not 2 or 3 is likely. Alright, and then spinning 10, well, as one of the characters mentioned previously, there's no 10. Look at it. 1, 2, 3, 4, 5, 6, 7, 8. There are only 8 parts of the spinner. There aren't 10 parts. There are 8 parts of the spinner, not 10. So it's impossible to spin a 10. Because it doesn't have a 10. It only goes up to 8. It doesn't have a 10. Look at the Touch and Teach Turtle one last time. I know, the nostalgia's killing you guys. 1, 2, 3, 4, 5, 6, 7, 8. It only goes up to 8. The highest is the sun. Think about the sun. The sun is the highest up in the sky. Like, when you look at the daytime sky, you see that the sun is pretty much the highest. So, the Touch and Teach turtle has the sun as its 8th and final key. You can analyze that and do analogies with that as the last number. 8. It doesn't have a 9 or a 10. So it's impossible to find the number 9 or 10 if it quizzes you to find a number 9 or 10. Because it doesn't have a 9 or 10. See? Same thing with the spinner. The spinner does not have 10 parts. And it does not have a number 10. It only goes up to 8. It's a 1 to 8 spinner, not a 1 to 10 spinner. So spinning a 10 would be impossible. Impossible. There's a 0% chance, which means it's impossible. Impossible. It's impossible. 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 I know. I keep saying that. We just want to reiterate this so that you know it better. It's impossible to spin a 10 because this spinner doesn't have 10 parts. It only goes up to 8 and it doesn't have a number 10. So that's why spinning a 10 would be impossible. And that's it from us today. I was trying to trick you by showing my camera to the next page and you thought, oh no, we're still continuing? But no, this is the end, because, look, it's the end of Lesson 14 and the start of Lesson 15. We'll go over Lesson 15 another time. But thank you for watching this video. I hope you enjoyed it. And I hope you can understand data better now. Because when you really do, your knowledge attracts. Aww. See you later. Bye. Come back another day for more math. Bye, everybody.